So let me write it down. This curve C has x is equal to 4t squared minus 24t minus 3 and a y to be equal to t plus 3 over t squared minus 1. So we are looking at a region that is between two graphs, okay, a region between two graphs. So for a region that is between two graphs, it is an extension of how we discussed about using these two situations, okay? So in our revision and in our outline for integration, let me just jump to the integration portion, okay? So for integration, we have this, okay? The area that is between two curves, okay? In case some of you, right, you don't really remember how we derive at this. This is a result, okay? This is a result that we base on this, and then we deduce that in order for us to find the area that is between two graphs, it is going to be integrating from x1 to x2, then the top graph minus away the bottom graph. I think in the exam, we should just use this directly. Okay, but just in case you have forgotten about the derivation, I really highly encourage you to go and take a look at our videos again, or just go onto the Achevas TV, click this portion, then see our derivation one more time. The derivation shouldn't appear in your script, but the derivation set the kind of mentality that we should have, right, to restrict our calculation to this 1 and 2. Okay, because we restricted ourselves, that's why we were able to come up with this and give a logical explanation to this particular formula, which we're going to be using it today. So number one, okay, if I were to refer to my resources, I know I'm going to be making use of this. Number two, because we are dealing with a parametric, I know I'm going to be dealing with this. What is it about this that we have discussed before? This is a formula that I don't want to use, right? We have talked about it. We don't want to use the parametric formula. Why is it that we don't want to use the parametric formula? Because area should be triggered by what we see. And for what we see here, right, this formula is something that is very close to us because we have gone through like sleepless nights, maybe, you know, we have gone through our O-level, we have gone through a major exam that tested us on this. And the good thing about this is it is very, very much related to the XY axis. Everything that is about here is X and Y. So physically, right, it is easier for me to associate this to the area because A is X, B is X, dx is the x-axis, then fx is the graph. You know, so it's easier for me to associate this formula to the shape that I'm seeing, where the area I'm supposed to calculate, as compared to this. What is the problem with this? This is t. Okay, you don't see t as much in your graph. Your graph is a Cartesian graph. Okay, it's on the xy axis. And because you don't see t, right, many times you will find yourself guessing. Okay, because this is not guess. This is I see, I put, I see, I put. That t, right, you don't see, so you just put. So you have to guess. You know, so the guessing thing makes this formula very, very inconsistent. So if you were to click this, or if you were to look at some of our past tuition video, right, you will see me explaining that, hey, there's a better way to do this. We will start with a Cartesian version first. Then we slowly do our substitution to get everything back into t. Then we do the calculation. Okay, we're going to try that on the board today also. So two things, okay. Number one, the parametric formula is one that I don't want to use, even if I'm given a pair of parametric equation. Then we are going to be making use of this formula to find the area that is between two curves. Looking at this question here, right, it gives us so much advantage, you know, according to what we have discussed. Because you know what's the problem? The problem is we have a Cartesian graph and we have a parametric graph. That's the problem. You know, for those people who can only use the parametric area equation, you know, to integrate, right, they cannot continue with this. It's not totally cannot, but it's going to be quite tough continuing with this. Okay, so what we are going to do is we will always start our area question by going for the Cartesian form first. Cartesian form. So for this, okay, although it is two graphs of different nature, one is Cartesian, one is parametric, but I'll start everything with Cartesian first. I am going to go for all the way to the left hand side minus 3, so minus 3. All the way to the right hand side 10, vertical line 10, so here is 10. And I can't put an fx minus gx for this case, okay, because it's top graph minus away the bottom graph. So fx, gx, I think I'm going to just go for a y. So I'm going to go for a y minus a y, like the top y minus away the bottom y, okay, instead of using fx and gx. But just to just so that we know that there are two different y's, okay? So for this particular y, I'm going to let this be y b, and for curve C, I'm going to let it be yc. Okay, so yb minus yc. I know that I cannot compute this together because this is going to become a Cartesian. This, I will do my own substitution to bring in all the t's. So I'm going to break up my integration into minus 3 to 10, and we have a yb dx minus integration from minus 3 to 10 of yc dx. Okay, we will be doing this. For this, I think it is easy enough. It is going to be integration from minus 3 to 10. yb is x dx. Integrating this is x to the power 2 over 2, integration from minus 3 to 10. As for this, we will do our own substitution. Okay, because what we are seeing here, this one is like my x1. This one is like my x2. So when, let me write it down. When x is equal to negative 3. When x is equal to negative 3, that means we have a 4t squared minus 24t minus 3 is equal to negative 3. This will be, if I were to solve for this, then t is going to be equal to 0, or t is going to be equal to 6. 6 is not applicable because the question says that t is between minus half to 0, okay? So this negative 3 will be replaced by 0. Then when x is equal to 10, that means 4t squared minus 24t minus 3, this is equal to 10. If you have to work it out, t is going to be equal to negative 1 over 2, or t is going to be equal to 13 over 2. So 13 over 2, again, I'm going to reject because of it is outside the domain of t, which means that this 10 is going to be replaced by minus 1 over 2. yc, it will be replaced by this t plus 3 over t squared minus 1. dx, from here, dx dt is equal to 8t minus 24. So here I will replace this dx by 8t minus 24 dt. Okay, then I do my own integration. It's a little bit tedious doing this integration, not impossible, not that difficult also. And if you have to do your own integration, you are going to derive at your answer. The answer is going to be equal to 99 over 2 plus 32 ln 3.